Today I'm going to talk about the software development life cycle with a tinge of application security. Are you able to hear me clearly? You okay? All right. This better? Okay. Before I even begin or talk about something, let me tell you a little story. There was a friend of mine who was working for a call center in India. His job is to talk to the American customers. He has to sell something to the American customers. So when he's talking, he has to ensure that he communicates to the customer. Sometimes he have to, talk that pep talk. Sometimes, "Oh, yeah, how are you doing? What are you doing? How is everybody at home?" And some questions like that, simple questions. Once what happened, he was talking to a customer, and this customer was every time telling that his 3-year-old daughter is writing something with a pencil, and just because she did not have an eraser, she was using spit to clean it. Then this guy, this Indian call center guy, he said, "Why don't you give your daughter the rubber to clean it?" Now, suddenly he got pissed off and he hung up the phone. He didn't understand what was the problem. Then later on, he went and asked somebody, "I told this American guy to use this rubber or give it to his daughter. Do you know what he meant by a rubber? He meant by this one, eraser. That's what he meant. But do you know what rubber means in America? Or most of them, they use this term rubber, or therefore, it's a condom." So now think about it. What did he tell them? He told, use a rubber, give the rubber to your daughter. So that's what we're going to talk about. We are going to talk about the communication that the security guys have with the developers. As we go on, well, a disclaimer for me. These are my comments, and it has nothing to do with the company that I represent. It might not be their views. How many of us feel that the breaches that are happening today are the cause of infrastructure failures? Raise of hands, please. How many of us feel that the issues that are happening today, or the breaches, are because of the application? Raise of hands. Wonderful. Most of us think that it is application. Some of us don't feel that it's anything. I'm just kidding. Yes, you are right. As you see, some of the problems that Gartner tells, 75% of the breaches are due to the security flaws in the software. NIST tells 92% of the vulnerabilities are because of our software. And yet 90% of the security spending is actually on the infrastructure. It's a little weird, isn't it? Okay. Now, what happens if in case we have this kind of a problems? We have revenue losses, loss from breaches on the internet. We have legal, privacy, regulatory compliance, corporate, and personal liability. These are the issues that we come across. And at the end of the day, loss of business and private and confidentiality information leaked onto the internet. And eventually the company is going to be dragged into the investigation, legality, so on and so forth. What are the application security issues that we're talking about? What we're going to do is we're going to see couple of examples, and then later on figure out what could have been a solution. The first thing, how about buying a product for free online? That's wonderful, isn't it? Let's see how that can be done. Have you done any online transactions? Yeah, we do, always. Have you seen a change when you enter your credit card and then hit submit? Before you get a reply back from the website saying that it's accepted or denied, did you observe the URL? It kind of flips. It doesn't really bother much till the time your credit card has been billed and you're able to buy the product. Now sometimes what happens is, There was one transaction that I did. I tried buying a product. This cost about $24,000. And I selected the product and I hit the checkout button. As soon as I do that, then comes the credit card payment gateway. So it's like, you have a payment gateway. So the architecture works like this. You've got the product page, then you've got the gateway, payment gateway, and then you've got the banks. There are 3 products involved if you look at the architecture. So you bought a product, hit next, and you're entering the credit card number here. If you notice, that credit card number is false. Ideally, it's supposed to deny you from buying anything. So what we did is we stopped it. We could have actually just stopped it in between, and then we try to see what is that URL about. And then you actually see that it's sending a status called as refuse. So once you hit OK on this one, or rather, at the end of this transaction, you will get credit card declined status. However, you've stopped it in between using a proxy, and instead of refuse, what happens? I changed it to authorize. You change it to authorize, and you let the transaction go through. Voila! You were able to buy the product for free. What do you think was the problem? We'll get to that just a minute. And then the application sends a mail saying that your product has been successfully purchased. Here you go, that's a mail. Fine. What could have been the problem over here? Simple thing, there are some things which they did not do. That is, number 1, the solution could be simple. Payment response should not have been routed to the client machine at all. It should have sent some kind of information back to the payment gateway from the bank, or from the payment gateway to the application. Payment gateway should directly respond to the application from the backend. Or maybe you can implement a hashing technique. These are simple. These, the developers know about them. They know how to fix this. Let's talk about another simpler example. There's this page. We're talking about the validations here now. This is a web page where you can buy some books. The cost of the book is $49.95, and you've got the quantity. You can select the number of, you can select the book. Hello? Yeah. You can select the book, and you can select the quantity of the book, how many books you want to buy. So what I've done is, I've selected the quantity as 1, and you hit next, and you can actually buy the book. Now the best part is, you right-click on the page and go to the view source. Now, this developer has put the validation in the client side. So you have this name-value pairs. You see that 3 over there? Instead of 3, you make it -3. Now that's the client-side validation. So you know that there's no server-side validation. Ideally, they should be having a server-side validation too. But in this case, it's only the client-side validation. So what happens? I've actually saved that copy onto the desktop, and then you can run it from your desktop as a local copy. So I've opened it. If you see there, it's actually running from my C drive. And now when I select the quantity, you have the different name-value pairs. You can select 1, 2, 3. But if you notice, earlier I've changed the name-value pair from 3 to -3. So now you've got this value as -3 there. So what happens if I multiply a certain number into -3? The value is going to be -3. So what does that mean here? If I buy 3 books, are they going to return my money? Let's see. Here you go. They're actually returning my money back. Well, to buy 3 books, they're going to give me money? Wow, that's a good deal. And if you notice over here, there's this value which is calculated as +6 for shipping and handling charges. Why do you think that has happened? Because that was calculated onto the server. And the rest of it, it's I'm so sorry. You can't live with or without them. I won't. Sorry. Who can live with or without the phones today? Okay, going back to it. I wonder if they're going to return my money back or are they going to put it into my credit card. Anyway, that's not the important issue. The important issue is the validation that was put onto the client side, it failed. So what was the concept over here? Why did the developer implement the validation on the client side? You know, being a security professional, you're going to tell them, implement the validations. Now, how is it that they have understood? Again, going back to the concept that I told about, the rubber. So we'll talk about that in a later. All these kind of vulnerabilities are still there. And there are different places where they mention of the vulnerabilities. One of them is OWASP, the top 10. You've got the White Hat Security top 10. You've got the SANS top 25. And there are other places where they mention about these security vulnerabilities. Let's try to concentrate on the OWASP top 10. We're not going to talk about all of them. We're not going to talk about all the security issues. However, let's try looking at that injection and cross-site scripting. There are some security vulnerabilities. We're just going to talk about injection, cross-site scripting. These are quite, these applications are, these security vulnerabilities are there from a long time. Okay, I've got a small video just for the people who wants to know what SQL injection is all about. I'm sure everybody knows about this, but I'm just going to run for the people who wants to know.
The site we are currently looking at emulates an e-commerce application. It could be Amazon, it could be Dell, or it could even be a candle store. This particular application is called Hack Me Books. What it allows users to do is browse for books, look at their details, and then purchase them. If the users have an account, then they can log into the application using their credentials. If the users do not have an account, then they can sign up for an account. To sign up for an account, the user needs to provide their username, password, and then some personal information like first name, last name, email address, phone number, and social security number is optional, but then he has to provide the password hint. Let's go ahead and sign up for an account. Let us choose the username as Brad. Password is password again. First name is Brad, last name is Jones. Mail is bradjones@mail.com. Phone number, we don't need to give that. Social security number is also not needed. The password hint, let's say don't need that, and click on sign up. Looks like the application threw an exception. This is very common. We all have seen exceptions in the web applications that we frequent to. Most of the users have learned to ignore exceptions. Most of them click back and try to re-enter a different set of values. But exceptions interest hackers and security professionals. Let us look at the details of the exception to see if there is anything interesting. Exception says process did not complete, details should follow. There are keywords like SQL exception. If we look at the exception closely, then we may find the backend SQL strings. Here is the name of the table followed by column names. Finally, the list of values that the application was trying to enter into the database. Looks like the single code that we tried to enter into the application caused the problem. This was nice. We caused an exception and we could see some internal details. But that's not good enough. Wouldn't it be nice if we could obtain other users' personal information? Now, there is no way a user can query that information by using the application. However, with the internal details that we just got, we can query the backend database and enter a new record which has users' personal information instead of a valid book name. To do that, I will create a malicious SQL injection string. What I'm going to do here is, instead of just entering a comment, I will enter a comment and add a SQL string to it. This SQL injection string is going to enter a new book in the database. But instead of having the legitimate details of the book, it will contain the personal details of another user of the system. So instead of the book's title, it will be the user's first name. The author's detail will contain the user's password, and the ISBN number will be the credit card details of the user. I will now copy this attack string and paste it in the password hint field. Let's see if that works. Looks like it did. The message says you have successfully registered for access to this application. Let us go ahead and log in the application now. We are now logged in the application. Let us go ahead and find the book record that has the personal details of another user. Click on Browse Books and look at what books we see. Here we see a book with the title Eric. That's a little strange name for a book, but this is the book that we entered using our SQL injection string. So let's go ahead and look at the book details. The book title Eric is user's first name. The author's information looks a little strange, but that's because the author's information is Eric's password in an encoded format. Finally, the ISBN number is Eric's credit card information. Once we have made a note of these details, we can eliminate the record from the database in exactly the same manner as we created it. A good attacker will make sure that he covers his tracks such that no one else can find out that he was here. One more important note that should be pointed out is that an attack like this can easily be scripted. Within a matter of a few hours, an attacker can query every single account detail from the database, make a log of it, and then delete everything that he entered. Several online stores have been compromised using SQL injection attack. A lot of them may still not be aware that they have been compromised and lost sensitive customer information.
The worst part about this one is, like it has been told, saying that you would never come to know, or many of the online stores would never come to know, saying that a SQL injection vulnerability exists, and there might be a hacker who might be actually getting into it, taking all the information and getting it out. Now, it would be too late for organizations to realize once it's happened. But if you look at it, this issue has been there from a long time. SQL injection has been there since the beginning of time, or rather what we call it as a security vulnerabilities, from the time it has evolved, from 2001 to be specific. Look at the graph over here. It's been taken from the CVE, and the issues, they are the total issue. The blue bar is telling you about the total issues, and the yellow bar tells you about the SQLI and the cross-site scripting. And if you notice, they are almost about 24.1%. Cross-site scripting is there from 13 years, and SQL injection is there from 14 years. And all of us know that these issues can be fixed with a simple code that you can actually implement. And this has still been a major problem today. Look at this one. It says it's 24%. 24% of all vulnerabilities are these since 2005. And if in case that's not enough, this one talks about the SQL injection breaches that has happened in January of 2013, which is 35.2%. All the breaches that has happened or which has been registered, 35.2% is because of SQL injection. And in February 2013, it's 31.3%. These issues are there. These issues have been there. And what are we doing about it? What is the fix for it? Simple thing. Everybody knows this one. It's input validation. Identify the data your application must accept, and identify the input points data will be received through. Define validation for each data type, and use whitelisting. Simple as that. And you can actually implement prepaid statements also. This is going to solve the problem. And ensure that your database do not have privileges to delete, modify. Now, focusing out of it. So far, we have been talking about application issues. We have seen some examples. And at the end of the day, we even told saying that this is the solution that can actually solve these problems. Now, if you look at it, the developers are humans at the end of the day. But still, these issues are not being solved. Why? Why? Let's focus on that. So, what did the security team do? They provide awareness to the developers. Fair enough. Provide induction trainings. Fair enough. Implement the stick rule. You say that you don't implement this, you will be given a warning letter, so on and so forth. Fair enough. Now, while you're giving them the trainings, we talk about the hacking, the way how the hackers get into your application. How can you actually get into any database? How do you retrieve the credit card numbers? So on and so forth. Fair enough. They will come back and tell you saying that we are very new to this and we don't understand. Maybe it's going to take some time to understand, so on and so forth. Fair enough. You can repeat this entire thing again and again and again. But still, why is it that they're not able to understand? There's something which is there which you're not able to communicate. Again, going back to the first thing that we were talking about, the rubber problem. I'm telling something and somebody else is understanding, or the developer is understanding something else. How can we solve this problem? Do we think we are actually going and telling the developers how to write the secure code? Are we sitting with them? Where is the human element? Is the human element brought into it? Would it be nice if we actually come back? We are there with you. This is how you write the code. You actually go to the code level and talk about it. You tell about how do you fix the code. Would that help? Maybe. Now, being a company, what is the maximum thing that we do? Now, you know that the application is not solving the issues. There are so many issues that we can't fix it in a given time or a given interval. So what do? You take the less obvious, or rather the obvious route of infrastructure controls. Going back to the question that we were talking about, where does the breaches happen? Infrastructure or the application? The best thing that we can do is a product vendor shows up at your doorstep. He's going to tell you, saying that this product is amazing. All you have to do is implement in your company and all the security issues are gone, like magic. And you say, yeah, let's give it a shot. You implement it. Then you say that this is not solving problem. The same guy will come back and tell you, we have another product which is going to ensure that anything which this can't do will be stopped by that. And so on and so forth. It keeps happening. You keep filling up your company's infrastructure with different kind of controls. Now, who is going to monitor that? Did you look at who is going to actually look at the monitoring? Is this going to solve the problem? I don't think so. Now, we'll go back to another concept completely. The future. Okay? There's something that we can learn from our own human body. We have this amazing capacity of healing ourselves. If in case you met an accident or maybe a cut, your body heals itself. Unless and until it's a too deep cut, yeah, it heals itself. Now, is there something that we can learn from it? The self-healing ability of a human body. How would it be if we actually implement this self-healing technology into a software? Do you think it can be a reality? It means you don't have to have a human intervention in order to heal your software. Say, for example, there's a vulnerability, it detects it and fixes it. It looks like a far-fetched dream. Maybe not. Maybe somewhere there's a research going on for this. By emulating processes that occurs in the human body and applying them to computers, IBM is leading the way in building self-healing softwares. This is quite an interesting subject. This project is called as Shadow. a self-healing approach for developing complex software system. This has been funded by the European Commission. There are about 7 or 8 companies with IBM who are actually developing this concept, or rather maybe they have already developed. And what does it do? It recognizes the issue, classifies them into possible types of problems, and makes appropriate adjustments. At the end of the day, how does it fix the problem? It inserts new line of code and moves the memory. So the way how this one works is, it's going to actually find out what is the problem based on some software code which is already embedded into the application, and then whenever the application tries to perform something else which is beyond the role of an application, it would try to insert new line of code in runtime. This is the new phase which is coming up. Now, the reason why I talked about this concept is about the future, because nowadays, if in case we're all security professionals, we know that the technology is moving ahead. We know that suddenly somebody in your company will pop up with an iPad, or they will just come up with a new mobile phone and they tell that I want to use this in the company from tomorrow. We as security professionals, are we ready for it? Do you know what are the vulnerabilities that it will bring into your company? Till yesterday, you don't want to put some sensitive information onto the internet, but now, because of somebody who comes back and tells that we need to implement this kind of control in the company, this new technology has to be embraced. Can we embrace it? Are we ready for it? New technology is there to stay. So it's better that we buck up. We understand what are the security controls that we need to bring in. Now, coming back, what we have seen so far. The best thing that we can do, follow the SDLC, follow security coding practices, reflect them in policies, procedures, and guidelines, ensure proper security testing is implemented, secure code training. Now, from the people aspect of it, less presentation, more exploration, and more secure coding, and keep an eye for the future. These are the 3 things that this is software craftsmanship needs to meet the security here. The main thing that I spoke about is the SDLC people, and keep an eye for what is new. Now, when I say about SDLC, there is this Microsoft framework phase where envisioning, planning, development, and stabilization is there. And in the software development lifecycle phase, it's a requirement gathering, design, development, testing, deployment, and maintenance. And when you implement the software security at the software development lifecycle, you have awareness, training, and education, which is spread all over across the SDLC. And in the envisioning phase or the requirement gathering phase, ensure that use and abuse cases should be mentioned, and policy, standards, compliance check is completely integrated into your requirement phase itself. And in the design phase, ensure you've done the risk assessment, data classification, threat and risk modeling would add value to it, and security test cases have to be implemented, I would say, included in the design. And in the development phase, it's a new thing which is secure code review, security code review. Nowadays, I believe there are a lot of source code scanners which can actually do this. And in the testing phase, ensure your vulnerability assessment and penetration testing happens. And it would be ideal if it is after the UAT, because keeps changing your design keeps changing in the UAT. Compliance checks, and in the stabilization, security sign-off, and in maintenance phase, ensure that assurance reviews keep happening. And maybe an external vulnerability testing, maybe this will help. I'm not telling over here saying that your company is secure. I'm not saying that. At least this is going to reduce the risk. Now, what about the applications that so far we have been talking about when you have control over the development? Now, what about the new phase that is happening where you are planning to outsource your development? Nowadays, many of the companies are planning to actually outsource. That's become because you see it as a value. you actually give this to a cheapest vendor who is planning to, who is going to do the development for you. What are the things that we would be thinking about while we are giving it uh, to the vendors? Is security more than just a side heading in your requirements document? I've seen some of the documents which actually have the security requirement. That is the only thing which is there. And a common sentence saying that the application should be secure. Wow, that wouldn't help really. When something happens, it's like, that statement is null and void. Integration of security with software development lifecycle. Do we check with the vendor saying that did they integrate security with the software development lifecycle? That actually helps. Secure training. Maybe you can actually check with the vendor saying that do you do any security training? So how important, what is the importance that they're giving for the security training? Unmanaged liability and unbounded risk. This is a very different concept. See, what happens is, as a company, you would think, saying that if in case we put some legality in there, saying that, what legality in there saying that if in case, if your company doesn't follow under the security rules, we would sue you. But when something happens, you're not really in a position to sue anybody, because the people who trust you, they leave the data with you, and then a breach happens, and you will be answerable to the people, however, or the customers, and the vendor is not really involved here. So it's unmanaged liability and unbounded risk. Is business given to the cheapest vendor? Just think about it. If in case you're giving it to cheapest vendor, what corners is he cutting? Is security one of them? If you're not looking into it, yeah, maybe security might be one of them. And some of the outsourcing checklists, have a good security policy in place. First of all, you be clear about your own policies. Select the right outsourcing vendor. A sound privacy and intellectual property policy. Protect your data. You have to protect your own data. Provide education on handling data. The rules of least privileges should be implemented. Leak-proof traffic. Ensure application and security audits. And ensure prevention technologies are employed. This is something which you have to take care while you're giving the application for outsourced vendor to develop. Some of the simple things: SDLC, security should be part of your SDLC. Outsource, security should be one of your primary concerns. And business logic, security should be an integral part of your business flow. And before I end, there's one more last thing that I want to talk about. So far, we have actually spoken about just the, we have spoken about three things: people, process, and we have spoken about outsourcing as well. Business flow. I would like to talk a little bit about the business flow as well, because so far we have been seeing that security vulnerabilities might be just the application related. Sometimes it might not be the case. I'm going to show you an example. This example is related to an online store where you can actually buy deals. The best part about this one is, if you notice over there, I think this vulnerability is not there anymore, but refer friends, get $30 rebate. If you see, the way how this one works is, if you buy a product from this website, it will be cheaper than actual rate. And the best thing is, they want you to refer to your friends. If you refer to your friends, and if they buy this deal, the first time that they buy, you would be getting money back. You will be getting $30. Now, this works like this. So they buy a deal, and you get $30. Now, every time that you refer a friend, it's not necessary that they might actually take the link that you have given and buy a product. However, what if you are a frequent buyer? You can actually create some fake accounts. So if you create fake accounts, you buy a $10 deal. So you being the first guy to buy, you referred yourself and you bought a $10 deal. So you would actually get $30 back. You buy $10, you get $30 back. You buy $10, you get $30 back. Simple maths here. Do you have to be genius to find out this? You actually made a 200% profit over here. It's like you spent $30 and you earned $90. You take out what you've spent, you've got $60. This is a business flaw. Maybe it is a business flaw, or maybe it's a business tactics. They want more customers. But I fail to understand, if I'm creating a fake account and buying a deal, how can be that a business process? I would categorize it as a business flaw. That's my choice. However, I would leave you at this one, saying that application security is not just about applications, it's also about your business flaw, it's about the people, it's about the future technology that's coming. So future technology is over here to stay. Thank you. If in case you have any questions, I'm okay to answer. Okay, thank you. Yeah, sure.
Could you give any advice how to introduce SDLC in already running project?
See, SDLC, there's a certain process that the Microsoft has already implemented in place. So it's more like a process, right? If in case you're following the Microsoft framework, your envisioning phase, you've got the planning phase, then you've got the development phase. Depends on which phase you are in. It's much better to implement the controls which are coming along with.
I'm in a project that is already there for about 10 years, and I have a lot of code and a lot of features and so on. So I need to introduce DLC in the...
At this point of time, see, once it is already implemented, there's nothing much that you can do. However, we can actually bring it to a point where we are actually doing some enhancements. If in case we are doing enhancements, then at that point of time, implementing SDLC on those enhancements and ensuring that the previously found flaws are also mitigated along with it would actually matter. And when you're fixing those issues, it's better that you implement the same SDLC that I spoke about. It should work. I mean, that's my intuition to it. And that's what even the Microsoft says.
Okay,
Thank you. Any more? Okay, thank you guys. So if in case you have any questions, maybe just catch me up over there. Thank you.